That sheet is gold, real gold, roughly 400 atoms thick. So thin, it turns translucent and drifts on a breath of air. It started as a solid bar weighing just 1 ounce, yet that single ounce will yield more than 100 square feet of finished leaf. The question isn't whether gold can be beaten that thin. It's how anyone does it without destroying it. At the heart of this process is gold's inherent atomic architecture. On a microscopic scale, gold crystallizes in a face-centered cubic lattice. This geometric arrangement provides 12 distinct slip systems, pathways, along which planes of atoms can slide past one another with minimal resistance. When struck by a hammer, these atomic layers glide like a deck of playing cards, spreading outward rather than fracturing under pressure. Unlike most metals, gold does not form a surface oxide layer. Without this brittle surface barrier, nothing arrests the continuous lateral flow of the material, allowing its surface area to expand while retaining its mass. With a lattice constant of 0.408 nanometers, the individual gold atoms are packed tightly together. Flattening this structure down to a thickness of roughly 100 nanometers leaves a cross-section of only 400 atomic layers. At this scale, the physical properties of the gold shift. The leaf loses its opacity, transmitting a faint, greenish-blue light while reflecting its familiar warm luster. Because the finished sheet contains so little mass, it becomes highly sensitive to the surrounding environment, shifting and rippling under the gentlest air currents. The core task of the goldbeater is to guide the metal through this transition, taking a substance defined by its high density and weight, and flattening it until it behaves like a delicate, weightless membrane. The work begins with a cast bar of 24-karat gold. At this initial stage, before any hammer strikes the metal, the objective is sheer bulk reduction. To compress this dense, heavy ingot into a workable form, the artisan relies on a high-precision rolling mill. Hand-fed between polished steel rollers, the gold is subjected to immense pressure. Industrial-grade mills employ a 4-to-1 gear reduction, allowing the operator to gradually close the roll gap in increments as fine as 0.1 millimeter. With each consecutive pass, the metal elongates into a bright, continuous ribbon. Because cold working structurally hardens the gold, the ribbon must undergo periodic annealing, heated carefully to its recrystallization temperature to restore its natural ductility. Through multiple alternating cycles of rolling and heat treating, the original 4.5 millimeter bar is reduced to a uniform ribbon only 25 micrometers thick. This early phase relies on industrial precision to prepare the metal, producing a highly consistent, flexible strip ready to be cut and stacked for the hand-beaten stages that follow. The 25 micrometer ribbon is cut into precise squares measuring exactly 1.3 inches. Working with these thin squares individually is impossible. A single hammer strike would tear the exposed metal instantly. Instead, the craftsman assembles them into a dense, layered stack known as a packet. Each square of gold is carefully placed between cushioning protective sheets, building a bundle that can hold up to 120 layers of gold. Stacking the metal this way serves a dual purpose. It allows the force of a hammer blow to distribute uniformly across the entire surface area, protecting the gold from localized tearing while ensuring every sheet thinned inside the packet expands at the exact same rate. This collective preparation turns a fragile foil into a solid, resilient block capable of absorbing immense mechanical energy. For this system to work, however, the interleaving sheets must endure thousands of high-impact blows without breaking down, sticking to the gold, or losing their elasticity. The search for a material that can survive this extreme environment has historically defined the craft. The traditional interleaf of choice is goldbeater's skin, a transparent, tear-resistant membrane processed from the outer serous layer of an ox's intestine. Measuring only 0.02 to 0.03 millimeters thick, These collagen-rich layers have a tensile strength of 50 megapascals. This remarkable durability allows the skin to withstand thousands of high-impact hammer blows without tearing or adhering to the metal. While modern workshops often substitute synthetic polymer films like mylar or low-density polyethylene, the animal membrane remains the historic benchmark for elastic recovery. The natural elasticity of the collagen allows the packet to self-level after every strike, distributing the force evenly so that all sheets thin at the exact same rate. Protected by this incredibly resilient cushion, the gold is ready for the heavy, rhythmic strikes of the beating phase. The first stage of beating begins with a 7-kilogram hammer, delivering rhythmic, glancing blows on a granite anvil. The artisan strikes at a 15-degree angle rather than straight down, letting the hammer slide across the surface. This lateral force coaxes the gold to spread outward like water rather than compressing. Throughout this round, the goldbeater monitors the physical feedback, listening for a clear, ringing metallic tone. A sudden, muted thud warns that a sheet is thinning unevenly or has punctured the protective layer, prompting an immediate adjustment in swing or packet rotation. Once the gold expands to the edges of this first packet, known as the cutch, the beating stops. The artisan opens the packet, cuts each enlarged square into 4 smaller pieces, and stacks them into a second, finer packet called the shoder. The process repeats with a lighter 5-kilogram hammer. A final recutting and transition to the mold packet using a 3-kilogram hammer coaxes the gold down to its ultimate translucent state. At this extreme submicron thickness, the gold leaf is too delicate for human hands. Direct contact with bare fingers is impossible. Skin oils and natural moisture would instantly tear the gold and prevent it from adhering to future surfaces. Instead, the artisan transitions from heavy hammers to the quietest tools of the craft. Opening the final mold packet reveals sheets so thin they float on a breath. To lift them, the gilder uses a flat, wide brush called a gilder's tip. By lightly brushing the tool against their own hair or skin, the artisan creates a faint static charge. This charge allows the brush to gently attract and lift the near weightless sheet without physical pinching. Using a flexible gilder's knife, the artisan trims each sheet into a standard 3 3/8 inch square. The finished leaves are then carefully placed between sheets of rouged tissue paper, ready to be sent into the world. These finished sheets, protected within paper booklets, travel to workshops and historic sites around the world. Gilders apply the gold to cathedral domes, ornate picture frames, and hand-lettered manuscripts, while chefs use food-grade leaf to decorate confections. In delicate preservation and restoration work, where absolute consistency and physical softness are essential, hand-beaten leaf remains indispensable. While factories employ automated rolling mills for the initial thinning, modern machinery cannot match human judgment in the final stages. Automated systems typically stop at a thickness of 0.1 micrometers to prevent tearing. A master gold beater, guided by the acoustic ring of the hammer and the tactile bounce of the packet, coaxes the metal down to 0.05 micrometers, half the thickness of its machine-made counterpart. This extreme thinning gives hand-beaten gold a soft, feathered edge that blends naturally with historic substrates and burnishes to a brilliant, reflective finish. A metal celebrated for its dense permanence is flattened into a weightless membrane, sustained by a manual craft that machines cannot replicate. In an automated world, this ancient craft endures because machines cannot replicate the human touch required at the absolute limits of matter. The goldbeater's judgment remains irreplaceable, bridging modern physics and living history. If this quiet mastery inspired you, consider subscribing for more stories of precise craftsmanship.